Hello everyone, can you hear me? Let's me. Okay, now you should be able to hear me well. Guys, first of all, I'm sorry that I started a bit late with 5 minutes delay today.
While I'm a paid actor.
So let me see if I can see myself. Yeah. Okay, awesome. How was the contest today, guys? Did you enjoy the contest? Was it good? I think we can now start discussing the problems. Let me just update my stream. How many problems you guys solved? Okay, so let's start discussing the problems then. So let me bring the first problem. Problem A. Only pluses. Okay, so as you can see in here, this problem says that we have three integers a, b, and c. So in order to as you can see in here, this problem says that we have three integers a, b, and c. So in order as you can see in here, this problem says that we have three integers a, b, and c. So in order as you can see in here, this problem says that we have three integers a, b, and c. So in order as you can see in here, this problem says that we have three integers a, b, and c. So in order as you can see in here, this problem says that we have three integers a, b, and c. So, as you can see in here, this problem says that we have three integers a, b, and c. So, as you can see in here, this problem says that we have three integers a, b, and c. So, as you can see in here, this problem says that we have three integers a, b, and c. So, as you can see in here, this problem says that we have three integers a, b, and c. So, as you can see in here, this problem says that we have three integers a, b, and c. So, as you can see in here, this problem says that we have Okay, now it should be fixed. Is it okay? Is the voice okay now? Okay. Okay, good. So when we have three integers a, b, and c, let me repeat everything then if the voice was not clear. The problem was this. We have three numbers a, b, and c. We can do this operation at most 5 times. Pick one of these integers and increase it by 1. And you have to say that what is the maximum final product that you can reach if you start from a, b, and c. You can pick one of them and increase them by 1 at most 5 times. Okay. So what I'm saying is that when you have three numbers a, b, and c, the product of them is maximized when they are as close as possible to each other. When we know that the sum of them is a constant value. So when you have three numbers and you know that the sum of them is constant, then their product is maximal when they are as close as possible to each other. In here, a and b and c, we can easily say that their values, the sum of their values is always a constant, because initially we have some a plus b plus c and we can add at most 5 to it, because any of these values we add by 1, the total sum will be added by 1 as well. So we start with a, b, and c, and we know that the total sum of them is a constant value at the end. We just want to maximize a times b times c. And in order to do that, we can say that it's the best if they're as close as possible to each other, because assume that we have two numbers. For example, assume that they are in sorted order. A is less than or equal to B, B is less than or equal to C. Just without lots of generality, assume that they are in sorted order. If C minus A is greater than 1, if the difference of minimum and maximum is greater than 1, we can easily say that A plus 1 times B times C minus 1 is better than AB times C, is greater than ABC. What is the reason of that? Because A plus 1 times B times C minus 1 is equal to, this is equal to ABC plus BC minus AB and plus B. Okay, sorry, minus B. Minus B. So when it's like we are just adding this number by C minus A minus 1 times B. And because C is greater than A plus 1, C minus A is greater than 1, this is a positive number, and B is also a positive number as well. So this value becomes greater than what it was before. So A plus 1 times B times C minus 1 is greater than A times B times C. So we showed that it is the best if the numbers are as close as possible to each other. So we can just say that 5 times is the best if we just add 1 to the minimum. Because when we have these three values, A, B, and C, if we add 1 to A, the total product will be added by BC. But if we add 1 to B, the total product will be added by AC. If we add 1 to C, the total product will be added by AB. The best is if we add 1 to the minimum. So each time we will add 1 to the minimum, and at the end we see that what is the final answer. Is it clear? Please use this emoji if this completely makes sense. Shall we move on to the next problem? Okay, so let's move on to the next problem, problem B now. Angry monk. Well, this problem says that we have a sequence we wanted to. We have a sequence and we want to merge all the numbers. We want to merge all the numbers. In each operation, we can pick a piece with length greater than or equal to 2 and divide it into two pieces with length 1 and a sub I minus 1. Or we can pick one a value ai and another value aj that is equal to 1 and merge them into one number. So each time either we can pick a number, like ai and turn it into such that ai is greater than or equal to 2. Turn it into ai minus 1 and 1. Or we can pick two elements like ai and another aj that is equal to 1 and merge them into ai plus 1. So when we merge one of them, the length of one of them should be 1. So now it wants you to say that what is the minimum number of operations to merge all the elements. Okay, what is the minimum number of operations to merge all the elements? Well, in here we can easily say that when we have these numbers, assume that we have sorted them. Assume that we have sorted these values. A1 less than or equal to A2 less than or equal to AN. I'm saying that all the numbers except one of them, should at some point get merged into another number. So I'm saying that for all the numbers except one, for any two x and y, we can say that at least one of them should become, for example, this y should turn into y1s and then added to another number one by one. So I'm saying that all the numbers except only ones, there doesn't exist two such numbers, except only one number, the rest of the numbers should be split into several ones and be merged to another number. And we know that for a y, if we want to merge it to another number, we need y minus 1 operations to turn it into y1s, and then we need y operations to add these ones to another number. So at least we need to add 2y minus 1 for this element. So we know that for all such elements that we want them to merge them into another number, we have to add 2y minus 1. So the best case is that if we choose the numbers with less values, so if they are in the sorted way order, it's the best if we choose a1 to an minus 1 for that. So the answer is gonna be the sum of 2 times ai minus 1 for I from 1 to n minus 1. This is the cost that we can give to merge them into the last number, into an. Does this make sense? For the first problem, is the maximum product we can get is actually, yeah, if a, b, and c could be non-integers, if they could be double, I'm answering this question. If they could be double and we could turn a, b, and c into anything, we didn't have limited number of operations, yes, that was the answer. But in here it's a bit different because our numbers are all integers first, and second, we can do an operation only 5 times, and if they are far away with each other, we cannot make them equal, so that's not possible. Can you show the code, please? I haven't implemented this code, I didn't participate in the contest, but I can show a code to you. Let me find the code to show to you. These codes are all Pythons. Yeah, you see that. For example, in this code, you can see that we have a for from 1 to k, and we see in 8, and we calculate the maximum. And each time we add a minus 1 to ans, in here, this is that y minus 1 to turn it into y1s. And then at the end, we see that what is the maximum, we subtract it for maximum, because for maximum we do not need to add that. We do not need to have that, and then we add n minus maximum to it. What is it doing? It's doing exactly the same thing that we wanted to do. I said that we can sort from a to a plus n, and then have a for I from 0 to n minus 2, I less than n minus 1. And we say that sum plus equal to ai minus 2 times ai minus 1. But we could also say that when we see numbers, we just say that for each ai, sum plus equal to ai minus 1. At the end, we say that sum minus equal to mx minus 1, because for mx it should not be calculated. And then we can say that sum plus equal to n minus mx, the sum of all the numbers except the maximum. It's like this is in here. We are calculating that y part. In here, we are calculating that y minus 1 part. So anyway, we are again calculating 2y minus 1 for all the elements which are not the maximum. Is it clear now? Shall we move on to the next one? If it is clear, please again use this emoji. Okay, so let's move on to problem C. Gorilla and permutation. This problem says that we have two functions, f of I is the sum of all the numbers in the prefix of length I that are not less than k. G of I is the sum of all the numbers on a prefix of length I that are not greater than m. So we have these two functions. We have to give a permutation such that it maximizes this value. Sum of I from 1 to n fi minus sum of I from 1 to n gi. So it's like we have f of I as sum of all the elements in the first I elements which are greater than or equal to k. So f of I is the sum of all the elements greater than or equal to k in the prefix of length I. G of I is the sum of the first I elements which are less than or equal to m. We want to give a permutation to maximize fi minus gi. But in order to make it interactive, you can also tell me your solutions as well for this problem, and for any of the problems. So anyway, for this problem, we can just say that we want to maximize this value. Sum of I from 1 to n f of I minus g of I for any permutation, right? Are you asking that from me? Do you have any girlfriend? Okay, anyway, that was a weird question in the middle of the stream, but anyway, so we want the sum of maximize the sum of fi minus gi. We can say that in order to do that, first of all, I say that I first sort everything in descending order such that first, at the first possible time, I mean the numbers which are greater than or equal to k come first, because we want to maximize sum of f of I. So it's better if they are first. They will be added this way very sooner. And it's better if they come in descending order in here, because first it's better to add the greatest number. And at the end, I just say that at the end for the numbers less than m in here, it's better to have them in the sorted way, because we want these values to be added as late as possible, and when we have to add them, it's better to add them from the smallest one to the largest one. And also do not forget that we know that k is greater than or equal to m. So first we add all the numbers greater than or equal to k in descending order, then the rest of the numbers can come in any order. For example, they can also come in descending order as well, and then at the end all the numbers from 1 to m. Okay, is it clear? My age is 24 right now, and my rating is around 2700. I don't know the exact. I think 2690 something. Yes, 2691. Okay, so I'm saying that for this problem, it's the best if the numbers greater than k come first, if the numbers greater than or equal to k come first, and the numbers less than or equal to m come last, so that they will be calculated later. I mean, if they come later, they will be calculated in less g of i's, and it's better for us because we want the sum of g of i's to be as least as possible. And for the values greater than or equal to k, it's better if they come first. So I first say that I will add these numbers greater than or equal to k at the beginning, and I put them in decreasing order so that the maximum comes first, and all the numbers less than or equal to m at the end in the increasing order, so that the least number comes first. And it's like we are trying to postponing adding them as much as possible, and we're trying to add as least as possible that we have to add each time. So this way we will gets the maximum sum of fi minus gi. Okay, Uday Chauhan, what do you think? What do you guess? So, anyway, is it clear? Shall we move on to the next round? If you are okay with that, please use this emoji. Let me also show you code for problem C. I guess maybe some people want to see the code as well. Problem C. Let me. Why everyone use Python in this contest? Let's read the Python code as well. It's interesting. In this problem, in this solution, it gets n, m, and k, and it just says that range of n, m minus 1 star of range of 1 to m minus. Okay. So m was the okay. I think that it's just calculating the sum of. Let me show you. Maybe it's better if I show you a C++ code to make it clear, but it was doing the same formula that's for this permutation that we were making. But anyway, these codes maybe are more clear. So let's say that in this one, it's just first, he is just adding all the numbers from n till greater than or equal to k in descending order, and then adds these values in some arbitrary order, and the last numbers should come from the smallest one to the largest one in the increasing order. So in this code, we are like exactly adding the numbers in the order that we set, and that's gonna be all. Okay, and if you want to also know about this Python code is just it's first adding all the numbers from n to m. It's a range n to m. This is all the numbers from n to m, n minus 1, n minus 1, n minus 2 to m, and then all the numbers to m plus 1, and then all the numbers from 1 to m. So in Python, it's just a very small code. Okay, so let me just write it here. This range n, m minus 1 is all the numbers from n to m plus 1. Then it writes all the numbers from 1 to n. Okay, is it clear? Why is Colin not giving contests these days? I don't know. So, shall we move on to problem D? Okay. Problem D. Loading. Okay, test of love. This problem says that it's like someone is going to swim in a lake or something, in a swamp, and you know, it's like we have n cells in each cell. In each cell there is either water, or there is a log, or there is a crocodile, and this person wants to start from the left bank and go to the right bank each time, where first of all he can swim at most k cells. He can swim at most k cells. When he's on a log, he can jump at most m, and he should never go to a cell that there is a crocodile in it, otherwise that crocodile will eat him. So let me also tell you this on tablets. We can say that this is the swamp that we're talking about. Each cell is either water that this person can swim, or there is a log that it can lie on the log, it can stay on the log, and from the log it can jump to the next cells, or there's a crocodile. If there's a crocodile, it should never go to that cell. The jumps from these logs or from the left bank, the jumps from the surfaces is at most m, and m is at most 10, and this person can swim at most k cells, and k is at most 2 times 10 to the 5th, and n is up to 2 times 10 to the 5th as well. So, well, when I see this problem, the first thing that comes to my mind is to think about, it starts, two ideas come to my mind. One is leafy and one is greedy. Both of them is possible. And if you see the tags here, we also can see both DP and greedy in here. We can see both DP and greedy in here. And I'm saying that, first, let's talk about DP. If we start from the end and come back, when we are at some cell, DP of I, assume that DP of I is the minimum possible cells that we should swim if we want to start from cell number I and go to the end. Okay, so this is DP of I. DP of I can be easily calculated. How? When you have the next ones, there are some possible ways. First of all, if there's a crocodile on I, DP of I is inf, because inf is a sign that we can never do that. Because inf, we are sure that inf is greater than k. If we set some DP equal to inf, it means that we cannot go there. So if it is a crocodile there, we can set DP of I equal to inf. Okay. If there is water, well, there's nothing we can do other than going to the next cell. We just need to swim. If we start from I, we just have to swim and go to the next cell. So it's gonna be DP of I plus 1 plus 1. Do you agree? So it's gonna be DP of I plus 1 this way. And if there is a log, we can jump to at most m cells in front of it. So it's gonna be minimum of DP of I plus 1 to DP of I plus 1, yes, to DP of I plus n. Because you can go to any of them and then start from there and go to the end. So these are the 3 possible cases, and because m is up to 10, we can just have a 4 in order to calculate this. And this way we can find the final answer. Is it clear? If it is clear, please use this emoji. So it's like we have, yeah, sure. I can repeat, yeah, sure. I'm just saying that DP of I is going to be, DP of I is going to be the answer, the minimum number of cells that we need to swim if we start from I and we want to go to the right bank. Okay, there are several cases when we are calculating DP of I. Okay, yeah, I will explain it without DP as well. I can start from I and I want to go to the right bank. DP of I says that what is the minimum cells to swim. Okay, we want to find the minimum swimming. So when we start from I, there are several cases. Either there is a crocodile there, or there is a log there, or there is water there. Okay, there are three cases. If there's a crocodile, then dp of I is infinity, because there's no way that we can start here and go to the right bank. So it's like we can say that dp of I is inf, because when we set dp of I as inf, we're sure that it is greater than k, and we can never do that then. So the inf means that it is impossible. It is impossible to start from I and go to the right bank. If there's a log there and there's a water, there are three cases. First, let's talk about the case that there's a water there, because it's easier. If there's a water there, I say that I have to swim to the next cell. So it's gonna be dp of I plus 1, and that's it. dp of I plus 1 if there's a water, because we have to swim to the next cell, and then from the next cell we should go to the right bank. So we have 1 swimming in here, and then the rest of it is dp of I plus 1. And if there is a log there, we can have a jump of length at most m. So the point is, for our jump, we can go to any of the cells from I plus 1 to I plus m. So we need to see what is the minimum value of dp of I plus 1 to I plus m. Okay. So because you can jump to any of them, and then from there we can go to the right bank. And this way we can just find out the minimum number of cells to swim. At the end, if dp of 1 was less than or equal to k, the answer is yes, otherwise the answer is no. Is it clear? Can you explain test case 2? Yeah, sure. Let me. At the end, dp of 1 should be less than or equal to k. At the end, if dp of 1 is less than or equal to k, it means that we can start from the first cell and swim at most k cells, and then we can go forward. We can jump on water. Yeah, the statement says that we can jump on water. It says that if he is on the surface, he can jump forward for no more than m meters. He can jump on the bank, on a log, or in the water. So you can also jump in the water. And about the second test case that you said, we can just start from the end. We can see that how DPs will be updated. We can start from the end and say that for this one, this is a log. We can just easily go to the last one. I mean, first of all, dp of n plus 1 is 0, because we are already in the right bank. We are already in the right bank, and we want to go to the right bank. We do not need to swim at all, so we're done. For this one, it's gonna be minimum of dp of I plus 1 to I plus 1, because m is also 1. So this one is also 0, this one is 0, this one is 0, this one is 0. For this one, it is a water, so we have to swim to the next cell. So it's gonna be dp of I plus 1 plus 1. So it's gonna be dp 0 plus 1, which is 1. For this one, we can only jump here, so its dp is gonna be this, so it's gonna be 1. At the end, we see that dp of 1 is 1, which is less than or equal to k, so the answer is yes. Okay. Is it okay? Okay, wait. So if you are okay with that, please use this emoji again. Otherwise, tell me to repeat anywhere. So this is the solution with DP, but there's also other solutions as well. And I will tell you about the other solutions too. There's also a greedy solution that we will talk about. Thank you very much. And guys, if you liked the video so far, if you liked the live stream, I would appreciate it if you like the video or subscribe to the channel. I believe that's gonna help the channel and my work to work better in future. Thank you. So let's talk about the other solution that we have. Well, I also have a greedy solution that I say that when you are on a log and you can go to another log, you can jump to another log, it's always beneficial to go there. When you are on a log and you can go to another log, I greedily say that I can always go to that other log. So it doesn't make my answer worse. So I say that if I'm on a log and there's another log as well, such that the distance is less than or equal to m, we can always jump on the next log. So for each log, we can just see that where is the next log. If the distance to the next log was less than or equal to m, we can just go jump to the next log without worrying about anything. Why? Because as soon that we do not go there, we will go somewhere else. Well, you can consider the first step that we pass over this log. The point is that wherever we go, maybe this is just the first jump or any other jump, we can just consider the first jump that we pass over this log. Whenever that happens, I could do the exact same thing from this log. So I could jump to that point from this log as well, and that wouldn't make any difference, right? So the point is that wherever I want to go, I could go from this log instead of this log. Therefore, I can say that it doesn't make my answer worse. So first of all, when we are on a log, it's always beneficial if the next log has distance less than k, it's always beneficial to jump there. Okay, do you agree with this? So this is the first thing that we say. Next, if there isn't any log in here, it's always better to jump as much as possible forward. It's always the best to jump as much as m. Why? Because first of all, we can say that if we jump here, if we jump to somewhere else, if instead of jumping here, jump as much as m, we jump somewhere else, anyway we have to swim one by one to come here again. So anyway, we cannot skip over here. Whether there's a crocodile there or there's water there, we cannot skip it. So anyway, we have to come here. So we can go there with one jump. And the point is that we can go there with one jump and there shouldn't be any crocodile in here. So if the distance was greater than, if the distance between this log and the next log, this surface and the next surface was greater than, there can be a log or a bank, or left bank or right bank. So if the distance was greater than or greater than the value of m, the point is that we have to jump m to here and then swim one by one to come here. So the only thing is that there shouldn't be any crocodile here, there shouldn't be any crocodile there, and we know that exactly how many cells we will swim. So greedily, I just say that either I will go to the next log or I will jump as much as possible and then keep swimming. So this way I can just run this greedy algorithm. So I have a 4, for example, I from 0 to n. 0 is left bank, n is the last cell. Each time I say that if I was on a surface, I was a surface, then I say that I see that what is the next surface. if the distance to the next surface was less than k, less than or equal to m, just go to next surface, else jump as much as m, so go to I plus m, and if it was not a surface, it was a water, swim plus the number of times you did swimming will be increased by 1. Let's say swim plus, and then go to I plus 1. And you should also say that if you had crocodile there, if crocodile, then print no, because then the answer is not possible. So it's a pseudocode that I just explained that how the procedure works. You can do this greedy algorithm, and you start each time. If you were on a surface, if we could go to another surface, we jump to that next surface. Otherwise, we see we are on the water and we go forward one by one. Okay, and we should see that how many steps we swim and if we saw a crocodile or not. Does it make sense? Why my messages has been removed, I don't know. You didn't remove them by yourself? I mean, I didn't do anything. Please make a video explaining a hacking contest. Okay, I will try to do that. Any other questions about it? If it is clear, please use this. Awesome. And guys, about the personal questions that you ask, we can talk about them at the end of this stream. So if you were interested about those personal questions, you can wait till the end and we'll discuss them. That's also fun, I believe. But first, let's talk about the questions. Okay. What if we are in a log and there are no logs to the right? Where there's always at least one surface to the right, because the right bank is also a surface. So this is the left bank and this is the right bank, and they are always surfaces. So you always have at least one surface to the right, because surfaces are not just logs, banks are also surfaces. So if the distance was less than or equal to m to here, you will jump right away. Which is more intuitive, your personal opinion? Both are very intuitive. I don't know which is more intuitive. It depends on which tag you're more comfortable with. It depends on which tag you're more comfortable with, because some people are more comfortable with DP, some people are more comfortable with greedy approaches and just do what can be proven to be the best action. So it really depends. Okay. But both of them seem intuitive. I don't know which one works better. Okay. So, shall we move on to the next problem? Can swim at plus k meters in water. Yeah. I personally first thought that it's just consecutive k meters. But then I saw that no, it's in total. Yeah, good. Good that it seems easy now. Awesome. So let's move on to problem E. For problem E, I didn't have a chance to think about it, so maybe we should read code together as well on this one. I unfortunately couldn't participate in the contest today and didn't have much time to think about the problems. So in this problem, I think it wanted that we have n friends, each one of them give A apples for the birthday of this person, and he will give back B of them. So anyway, we want that n times A minus B, when we see n as a string, we want it to be equal to the real value of n times A minus B. How many pairs AB exist for a given n, satisfying the constraints of the problem on each? Okay. So for a given n, you need to find out which pairs of A and B work well for them, and what you calculate is gonna be correct. Because do you have any idea? Maybe we can discuss it together. Do you have any idea about it? I can also see the codes, but I will. I mean, once we can also try to think about it and solve it right now, because it doesn't seem to be a hard problem. We have some number n, and B should be up to this. Let me bring some code. Again, everything is in Python. Let's see what has happened in this code. String S to string of n. A should be at most 10,000. Okay, in here we're just seeing that what is the number. I mean, this minus 48, I think 48, it should be ASCII code of 0. Yeah, 48 is ASCII code for 0. It's like we want to see what is the number in here, what is the real number. When we subtract 0 from it, we know the real integer value, and we are keeping num. Okay, yeah, it's just brute force. So this is up to 10,000, and and yeah. Okay, let me explain it to you. Okay, so let's talk about it step by step. So let me first tell you the question once again on tablets. So we have some number n, and we want to find out, we have some number n, we want to find out for how many A and B's if we copy n A times, and then remove the last B characters, we're gonna get n times A minus B. In how many ways? These two are equal. If we do this procedure, write n A times, concatenate n A times, and then remove the last B letters, it's gonna be equal to n times A minus B. We want to calculate that, right? So okay, so what we can say is that first of all, we know that we know the constraints. We know that A and B should be both up to 10,000, right? A and B are both up to 10,000, and n is up to 100. So what we can say is that this number n times A minus B is at most 100 times 10,000 minus B, so it's at most 10 to the power of 6. So first of all, we know an upper bound for this. It's at most 10 to the power of 6, right? So we know that this number has at most 7 digits. N A minus B has at most 7 digits. Do you agree with that so far? And that's a big point, that it has at most 7 digits. Why? Because we can start from the beginning, and for each n, we can see that what B should be at least. You know, we know that n has several digits. N has at least, n is at least 1, right? So we can say that if we write n several times, we know that B should be a value such that at the end there shouldn't be more than 7 digits left, because otherwise that value is definitely greater than n times A minus B. So at the end there shouldn't be more than 7 digits left. There shouldn't be. So what we can say is that for any n, first we have a 4 on A. That's what our A is going to be. And then we're gonna have a 4 on B. The point is that B should be in a way that at the end there would be at most 7 digits left. So our 4 for B has 7 possible values, and then B will be fixed. A is also fixed as well. A has 10,000 choices, so we know what A is. Right now we know n. We have a 4 of 10,000. Then we know A as well. And now we have a 4 of 7 at most, or let's say 10. Then we know B, because we know that B has at most 10 choices. Then we have B, and when we have A and B and n, we just check if n times A minus B is equal to the first, you can see what is this size, right? You know that size of n is something times A minus B. You know that's what is gonna be the size of that. It should be equal to the prefix of this size of repetitions of n's. So each time you can just check that out if they are equal to that or not. The point is that our 4s are gonna be 10,000 times 10. The main important point is that the second 4 has size at most 10, and that's gonna make it, and that's gonna make our code efficient. So A has 10,000 choices and B has 10 choices, because at the end the number of remaining digits cannot be more than 10. So this way the answer can be calculated. Yeah, a n time minus b is at most 10 to the 6 minus 1, so there are at most 6 digits. Yeah, if I want to be precise, I could also say that the number of remaining digits is at most 6. That is right. Is it clear? So let me also show you the code once again as well. So what you see here in the code, you can see that in here first we have a 4 of this size, then there is a 4j such that j is at most 10, as you can see in here. It could also be 6, that doesn't make any difference because it cannot be 7 to 10, but there's no difference really. It doesn't make it very slower to go to 10, have some upper bound. And then we see that what is our number if we go till there. We just store that. What is our number if we consider the first j characters of these repetitions of n? You see that you have some s that is a string to a string of n, and then we make some copies of it such that we have enough n's. So that we know that when we want to see a prefix of it, we have enough letters to see that prefix. So each time we see that, we say that num times 10 plus this, so we know that what this number is right now, and you check that, you know that what b should be. B should be size of s times a, the first size of s, the initial size of s, times a minus j. B should be exactly this much, because we know that j characters should be left. The length of the new number should be j. And you check that if n times a minus b was equal to this num, and b was not 0, because b should be at least 1, then vec dot pushback pair of a and b. And this way your final answer can be calculated. Does it completely make sense? As I said, s of j minus 1 minus 48, this 48 is nothing but ASCII code of 0. The ASCII code of 0. So it just says s of j minus 1 minus the ASCII code of 0 because s of j minus 1 is a character. For example, it's 7. When you subtract the ASCII code of 0 from it, you see that the difference between the character 7 and the character 0 is equal to 7. So it's like you get the number 7. By subtracting a character from character 0, you get the real number of it. So for example, if you have character 5, when you subtract character 0 from it, you're gonna get number 5. So when you're calculating your number, because you need the real numbers, you don't want the characters, you want the real numbers, you don't want character 7, you want 7 itself. So you need to subtract character 0 from it and see what is the real number in there. Yes, that is ASCII of 0. Yeah. So is it clear? I don't know why it keeps. Okay. Yes. Okay. How long it takes for you to solve 1400 rating problem? I don't know, it depends. You can see my performance in the past contests. I think that shouldn't be long. Yes, D is done. So if it is clear, please again use the emoji so that we will move on to the next problem. So let me know if the solution for this one was clear and or if you had any questions about it. You can solve it in constant time with bit of masses. Really? If you had a solution, you can say that. Thank you. Okay, sure. So let's now move on to problem F. I haven't read the problem F, unfortunately, but that's okay. We will solve that. So let me see that what problem F says. Valuable cards in his favorite cafe. Okay. And cards with prices for different positions are laid out in front of him. On the ith card, there is an integer a sub I. Into minimum number of bad segments. Which is impossible. Okay, so a segment L to R is bad if there are no indices I1 to Ik such that the product of them is equal to X. Minimum number of bad segments, so that is if it is impossible. Okay, the minimum number of bad segments that we can. So we are given n and x. We want to split it into minimum number of bad segments so that in each bad segment there are no subset of values such that the product is equal to x. Okay. So it seems like one of you has a solution. We can iterate from 1 to n and store all products of it. Okay, so you have a greedy solution. My CF username that you asked is Shayan. Okay, so let's also see a code. So yeah, in these problems also DP and greedy, and yeah, what you said was also a greedy solution. Let's see this code. It's from Ishmael. Let me make sure if it's from Ishmael. It's my friend. I think he was in NAC. So let's see. We have n and x. Each time we say that if y modulo a, y is on set S, okay, interesting. So we have a set S. Okay, first of all, we use a greedy approach. I want to explain on this code. So first let me, now that I know the solution, let me tell you the statements once again. The exact statements was that we have this sequence and we want to split it into minimum number of segments such that in each segment their product is not divisible by x. Okay, in each segment their product should not be divisible by x, right? Not divisible or being equal, just let me. Yeah, there's no subset such that their product is exactly equal to x. Okay. So we have an array. We want to split it into minimum number of subsequent subsegments, such that in each subsegment there isn't any subsequence, such that the product is exactly equal to x. Right? So how can we do that? How can we find the minimum number of sets? Well, the point is that in here we can just say we can keep a set. In this set we just store that what are the numbers that we shouldn't see. Well, first of all, it's easy to say that we can use a greedy approach. We can use a greedy approach if we can continue an interval. First of all, we start an interval from the first point. And as long as we can keep this subsegment, as long as we don't have x, we can continue having it and do not start another interval. So we can greedily move forward, and each time if you can add an element to the existing subsegment, just add it. Otherwise, start a new subsegment. So if you can add it, be greedy. And if you can add it to the current one, just add it. If you can't, if you can add it, just add it. If you can't, start a new interval. Okay, so first of all, we can be greedy. The first thing that we can say is to be greedy and try to have your interval as long as possible, and do not end them until you do not need to end them. And then you can have a set S such that in S you keep all the values that you should not see. Okay, so in S you keep all the values that all the values that you must not see, you should not see. Because if you see them, you can say that you have x. Initially in S you can just have x itself. Initially in S you can just have x itself, because only x shouldn't be seen. If you see exactly an x, then you have product of equal to x. So initially you can say this, and then you can say that each time when you add another element, you can have a for on your sets. If there is any elements in your sets such that is exactly equal to the element you have right now, then definitely you should not add it to this subsegment. Otherwise you have x, and you should start a new one. Otherwise you can just say that for any, for example, y in your set, for y in your set S, first of all, if y was equal to a, then you need to end the current subsequence and start another one. End the current one, start a new one in this case. Otherwise, because when y is equal to a sub I, it means that we have seen one of the numbers that we shouldn't be seeing. So the product will be equal to x afterwards. Otherwise, else, if y was divisible by ai, you can just add to s, you can insert to s value of y over ai, a sub I. Because if y is divisible by ai, then if later on you will see y over ai, you can keep that y over ai. You can have that y over ai and have this ai, and their product is going to be y. And y is something that you shouldn't have, because if you have y, you can, it means that you have x over y already and their product will be x. So if you shouldn't have y right now and y is divisible by ai, from now on you shouldn't even have y over ai. Okay, so you can just add that value to your set as well. So that is all that we're gonna say and we're gonna do in this problem. We're just gonna have a for on our set S. If y was divisible by a, if y was not divisible by a, continue. Otherwise, if y was equal to a, then we should start a new interval. So we say ans plus plus, and we start S as x and x over a. Why? Because we shouldn't have x, but we shouldn't also have x over a, because right now we have a, and if we have x over a in future, then their product is x, and then we just in place y over a, or insert a y over a to our set. This way the size of set will be at most equal to the number of divisors of x, which is of O of a square root of x, for example. So it's even of O of a square root of root of x in base 3 as well. So it's gonna be at most around 100 divisors for each x. There's gonna be at most 100 divisors for each x, and then we can just say that we can have for each one of them, we can have for each of these values of n, we can have a for on those values, and if we see one of those values, we just start a new interval. Otherwise we insert another value to our set, and this way we can find out the answer. And time limit is also 4 seconds, so with these limits it's gonna be okay with this time complexity. Is it clear? Please again use these emojis if you're okay. If you're not, tell me to explain again. Shall we move on to the next problem? Problem G. I think G is the last problem of the contest. Yes. So shall we move on to that problem? Okay. So let's move on to problem G. Problem G states that, I haven't read this one as well, so let me read. What does it say? We have an array A of length n. Sum of mix of b and size of b plus 1 over all distinct subsets of the array A. Okay, so for each subset of A, you want to find out mix of B and size of B plus 1, and you want to add these values up. For example, in here you have 5. What is this? Okay, consider number 1 to n. Okay. So when you have 2, you have 1, 2. You have 1, you have 2, you have 1, 2, and mix of 1 and 1 is gonna be 2. Mix of 2 and 1 is gonna be 1, mix of 1 and 2, and 2 is gonna be 4. So it should be 7. But it isn't. Let me. Why it is 12 for 2? If it is 1, mix of 1 and 1. Oh, size of b plus 1. Okay. So for 1, it's gonna be mix of 1 and 1 is gonna be 3. For 2, mix and 1 and 2, mix of 2 and 2 is gonna be 3. For this one, mix of 1, 2 and 3 is gonna be 5. So it's gonna be, I think, 5 plus 3 plus 3. Is it right? Oh, also empty sets. Also empty set, great, yeah, you're right. Also empty set, so for empty set it's also 1, so it's gonna be 12, right? Right, great. So yeah, it's gonna be 12. So, okay. So we want to see for any subsequence, what is the mix of number size plus 1 of this subsequence, and you add these values up. Okay, seems like an interesting problem. And you know that the sum of n squared over all test cases does not exceed 25 times 10 to the 6th. It's interesting. So let's again take a look at Java's code. This is a very interesting code. Okay, this is binomial. This is the binomials. He has calculated all the binomials. And because we have all the numbers from 1 to n, that is also very important. Okay. So you have size from 0 to n. For each size, he has a 1 to n plus 5. K minus s at minus 1. Okay, so he's talking about some specific size S set. Guys, I will explain the solution in detail while I know it completely, but for now let's just try to figure out for each possible size S set he has a 4k. I think he wants to count in how many of the subsequences their answer is k. So he says that what is k minus size minus 1. Okay. Okay, if the answer is gonna be k, it means that if the answer is gonna be k minus size. Okay, so I think that this value k is for this k, we know these values before it. We know that at least if size is sz, at least sz of these numbers shouldn't be chosen. Sz of these numbers shouldn't be chosen. Exactly. right? So k shouldn't be chosen if k is the answer. If the size of my array is size, and my s set plus 1th mix is k, s set plus first mix is k, it means that k should not be chosen, and exactly s set of these values shouldn't be chosen as well. So how many should be chosen from 1 to k minus 1? K minus 1 minus s set should be chosen. So behind it, k minus s set minus 1 should be chosen. Exactly. And b is s set minus a. So b means that how many numbers should be chosen after k? From k plus 1 to n. If minimum of a and b was greater than or equal to n, just say that ans plus equal to choose of minimum of k minus 1 and n, choose a from k minus 1 and n. From the first k minus 1, you should choose a of them. Why minimum with n? I don't think this minimum with, oh. Yes. Because we should consider all the numbers from 1 to minimum of k minus 1 and n, right? To minimum of k minus 1 and n. Because the numbers cannot be greater than n, but they cannot be greater than k minus 1 as well. A of them should be chosen times from the rest of them maximum of 0 and n minus k, b of them should be chosen times k. And this way it's gonna be calculated. I will tell you the solution all from the beginning once again, but is it clear so far? I mean, is it clear for any of you? Just so far? Oh, I think you couldn't see my screen, unfortunately. I guess. Okay, so let me explain the full solution to you once again. I will explain you the problem and the full solution once again. So, problem G. This problem says that you have a sequence of length n, 1, 2 to n. For each subsequence, for each of the subsequences, you say that you have some mix of b and size of b plus 1. You add this value. And what is this? This is mix of some array a, mix of some sequence, let's say s, and k is the kth positive integer that is not in s. Integer not in s. So for each subsequence b, you want to find out the mix of b and size of b plus 1. Yeah, it is problem G. And you want to find out the sum of these values. Well, the point is you can have two force. We know that the sum of n squared, as the problem statement says, the sum of n squared over all test cases do not exceed this much. So we can have a 4 of size n squared then. So we can have the first 4 on my size, on the size of my sequence, my subsequence, which can be from 0 to n. And then I have a 4 on my value of mix. What my mix should be? Okay, my mix is again a value from 1 to at most 2n plus 1. Okay, or I could also say 2n plus 5 like in this code. In this code he has used 2n plus 5 because it's okay. I mean, he's just being safe. I mean, he just adds 2 or 3 additional values. You could also say 3n. But the point is, the answer is not more than, the mix is not more than 2n plus 10, right? So your second form, your mix can be only from 1 to at most 2n plus 10, because your mix cannot be greater than 2n plus 10. So this way you will consider all the cases. Even 2n plus 1 could be enough, but we're just being safe. Okay, let's consider all the mx's from 1 to 2n plus 10. We want to see that how many subsequences of length size sz have their value to be this max. Well, the point is that when you set this max, let's call it k. Let's call this max k. You know the size and you know that what your max is going to be. Your max is some value k. Well, the point is, first of all, we can say that k should not be chosen, definitely. And also, from the numbers before k, from the numbers from 1 to k minus 1, at least, exactly, not at least, exactly k of them shouldn't be chosen. Should not be chosen. Such that the max number size plus 1 of them, not k of them, sorry, size of them, sz of them. Sz of them should not be chosen because we care about max number sz plus 1, so there should be exactly sz elements before it that are not chosen, so that k is sz plus first elements that is not chosen, right? And then we can say that how many ways do we have it for that? We say that how many elements should we choose from the elements before k. From the elements before k, it is from 1 to minimum of n and k minus 1. From these elements, a of them should be chosen. A is equal to minimum of n and a is equal to k minus 1 minus sz. Because I know that sz of them should not be chosen from the numbers from 1 to k minus 1. So k minus 1 minus size of them should be chosen. All those numbers should be at most k minus 1 and also should be at most n, because we cannot choose anything greater than k. So I should choose these many numbers from these elements, and from the rest of the elements from k plus 1 to n, we should choose b elements. B is equal to sz minus a. So we have two binomials. We just need to choose minimum of, from minimum of n and k minus 1, we should choose a of them, and then from the rest of the values, from the n minus k values, I can say max of 0, and n minus k values, we must choose b of them. And we should just multiply these two values, and we have all the number of ways that we have a subsequence of size sz such that the max is k, and we should just multiply this value by k and add that to our final answer. And that's gonna be all. Is this clear? Again, please, if it's clear, use this emoji. If any part is not clear and you need further explanation, feel free to tell me to explain that part again. Awesome. So, do you have any further questions? Okay, if there are no further questions, then I think I'll see you next time. So thank you very much again for joining. It was so nice having you in here. and I hope I can see you the next time very soon. Thank you guys.